Yeah, Levi, erase that blob.
Oh, you caught me. I'm in the hallways of Harvard and working on a very complex math problem. I must be very smart.
You need therapy from Robin Williams.
Yeah, but I'm gonna reject him at first and be mean to him about his passed away wife.
Those are your defenses from your rough childhood.
Right, but it's not my fault.
It's not your fault. Hey, it's not your fault.
Stop it.
Don't you know
Stop it.
that it's not your fault?
Stop. Oh!
Do you get it now?
Yes, all my problems are fixed.
That's all that it takes.
Then you make a movie about it. That was actually their relationship in real life at the time.
No way.
Oh no.
You know, I didn't realize that it was about a guy named Will Hunting. I thought it was like, hey, you're gonna go hunting? Here's Goodwill. I didn't know. I just didn't know.
You just didn't know. It's not your fault.
There is no way for me to know. Don't you see that?
I see that. I also see that every time you exhale, the breath goes out the eyeball holes of that mask and fogs up your glasses.
Well,
I really hope they can see it, but unlikely.
That's how lions work.
Oh, they breathe out of their eye holes?
Yeah, did you not know that?
I didn't know that, but it's not my fault.
What do you think about the two of us doing a sick dance break?
I feel pretty good. 1, 2, 3, go!
You've got to do better than that, Mr. Levi. Are you okay?
I'm okay, but my marker's not.
You're ruining the dance break. 7:30 to 9 p.m. Eastern Standard Time.
1, 2, 3, let's go. Hello! How are all of you?
I'm going to put this on the other screen. Levi, keep doing that. It's going really well. Everybody's here. Everybody's ready. And we're going to get started right... Hey, Here in the Moment. Welcome. Is Here in the Moment always Here in the Moment?
Can't not be.
That's true. You could be far away in your head. And also you could be elsewhere. Like right now, Here in the Moment's not actually here. Here in the Moment's there. There's also a lag.
Here in the moment, do you have any questions for us? How is this C?
Oh, Levi, Here in the Moment's got something for you.
Oh. Thank you. You do? One moment.
We can wait a moment, but nothing more. But we're going to assign 1 moment the duration that it takes you to come back with your question.
Mm-hmm.
So it will take exactly 1 moment. It's going to work out really well. These little thingies here. I'm going to get rid of these. Mouse right there. There we go. That's good. That's good. We like that. Everything's going well. Absolutely. Very good. We got any questions for our stream leave? Master leave word. Master leave word. Any questions?
Master Brady.
On the stream, Master leave word?
Not here.
Not now. Not here.
Do we have Discord?
We have Discord. That's where people send us questions. Come on, something come out. Impurities in the glass, my lord.
Yes.
Well, I could probably get them out. But buff out these scratches a little bit of juice. Okay, check the ACT Reddit, please. Oh, put it on Reddit. Okay.
Yes. Here in the moment, yes.
Levi, could you get on that?
I'm on it right now.
Yeah, but like, could you get on
Oh
it?
boy, the heck?
Oh, I want to do this one.
Okay, I'll set it up for you.
Okay, Here in the Moment. Yeah, we see the bad word. We will not condone the bad word, but we will help you solve this problem.
He is not one of us. Da, 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 da. I don't know what song I'm singing.
Was that even a song?
No, it was not a song. It was a dumb comment.
Yeah, it did sound like a dumb comment.
You sound like a dumb comment.
Who, just me in general as a human?
Yeah.
How does that even work? You're setting me
Do you
equal.
agree, Birdie?
You're setting me equal to something that I'm.
All
could
right.
not be
Do
equal
you?
to.
Can you do this, or do you want the answers here or no?
Can you? Yeah, take the answers up. Very good. All right. You can make it smaller a little bit. There we go. Good.
In size or weight?
A basket contains 10 solid colored balls. 2 blue, 3 red, and 5 green. Each ball has a single number printed on it. The blue balls are numbered 1 and 2. Each number is used only once. The red balls are numbered 1 through 3, and the green balls are numbered 1 through 5. A ball will be drawn at random from the basket. What is the probability that the ball that is drawn will be red or have a 3 printed on it? So I know what you're thinking. Your general strategy here for an or question is you add the probabilities together. So we'd say, okay, so probability of red or 3 would be equal to the probability of getting a red plus the probability of getting a 3. And that's going to equal, let's see, the probability of getting a red. There's 3 red out of 10. And then the probability of getting a 3, it looks like there are 2 different number 3 balls. So that's going to be 2 out of 10, which gives you an answer for 5 out of 10, or 1/2. And then you get the question wrong. And you're saying, what did I do wrong? What happened here? Let me give you a slightly different scenario, and I think you'll understand. So let's say we have 4 cards. They are playing cards. And we have numbers on them. We have a 1, a 2, a 3, and a 4. And let's give us some colors. So let's say we have 2 pinks. So we got pink, and then we have 2 blues, blue and blue. And I wanted the probability of even, the probability of blue, and then the probability of blue or even. Probability of even, there's 2 even numbers, 2 and 4. So 2 out of 4, 1/2, great. Probability of blue, there's 2 blue out of a total of 4, same thing, 2 out of 4. And here's the kicker, blue or even. Let's look at the numbers that are, let's look at the cards that are either blue or even. Is this one blue or even? No, it's not. Is this one blue or even? Yes, it is, because it's got a 2. Is this one blue or even? Yes, it's blue. Is this one blue or even? It's actually both. Blue or even means blue, even, blue and even. That counts as well. If you said, hey, is this card blue or even? The answer would be yes. There are 3 cards here out of a total of 4. One of these cards is both categories. We cannot count it twice. With this problem here, there is a red ball that has a 3 on it. So what you've done here is you've counted that ball twice. Once in the red category, once in the 3 category, which means you've double counted it. So what you need to do is add them together like you did before. Probability of red plus probability of 3, and then you just double counted that, the 3 red balls. So you have to subtract the probability of basically the red 3. Because then you'll only count it once, which is what you want to do. So this will be 3 over 10 plus 2 over 10 minus 1 over 10, giving you 4/10. Oh, geez, I'm off the screen. Giving you right here. Giving you 4/10 probability. Okay? There is an overlap here. You've got to be careful. Okay? So we had, oh, that's a nice marker. Here's red. Here's 3. In certain probability situations, there's no overlap. They're totally exclusive. They're mutually exclusive from each other. This one is not a situation like that. They do depend on each other slightly because they have this overlap. So when you counted the red plus the 3, basically you said, okay, let's add the probability of this with the probability of this. But as you can see, you double counted the middle, which is why we have to only subtract it once.
to get it back to just counting it once. Here in the moment, what are your thoughts on that? Does that make sense? Did you like it? Did you dislike it? Do you feel absolutely nothing towards it? Do you feel anything towards me? Do you feel anything towards Levi? Yes, thank. Very good. Levi, can you put that on Reddit?
I did.
Very good. Here in the moment, you're welcome. If that's how we're going to play this. Uploaded more questions. Oh. Okay.
Let's go back to Reddit ACT. You want to get the next one, Levi?
What next one? Does Here in the Moment have a question?
On the Discord or not? Well, it looks like on Reddit. There's nothing on Reddit. So
Here in the Moment, was that your question on Reddit or was that someone else's?
It was.
Oh, okay, got it. Oh, I stood up too fast. Brady.
Why does that always happen to you?
Oh, it always happens to you.
No.
You're my business partner.
That's true. Okay. One ACT.
Is there another one?
Here we go. There is another one.
Oh, there's another one.
Oh, there's a couple of them. All right, must leave one.
Sorry. Can you start erasing that stuff over there?
I mean, if you want me to.
All right. So we have in the diagram below, B, F, and H are on AC. What? B, F, and H are on AC, AE, and BF respectively. Sure, that makes sense.
Like it's on the diagram.
Yes, it's on the diagram, sure. And GH is perpendicular to BF. GH, so they've labeled that as well. Great. The area of the square ABGF is 1/4 the area of the square ACDE. Okay. What is the percent of the area of ACDE? Oh, what percent of the area of ACDE does the shaded portion represent? So you have 0.0625%. My guess is this is a decimals issue here. Here in the moment, how did you do this? You saying it makes no sense leads me to believe that you did... So what did you do here? Did you do 1/4 times 1/4 and you got 1/16? Because yes, okay, so you have 1/4 of 1/4, which gives you, since this is multiplication here, you get 1/16, which then would equal 0.0625. You're about to be a little bit frustrated, by the way. Yeah, so that's all right. The issue here is this is not a percentage, this is a decimal. So to make it a percentage, it becomes 6.25%. Those are equivalent, okay? So percentages are out of 1. So the number 1 is the same thing as 100%. You multiply it by 100, right? So the number 1/2, of course, 1/2 of something is 50% of that thing, right? Because 1/2, that equals 0.5, which then would be 50% when you multiply by 100. Does that make sense? So you did the math right, it's just the terminology you weren't paying attention with. It's weird to see decimals and percentages at the same time. Just remember that the percentages still is there. That's it. Yes, I know that's a little frustrating, but that's all there is. Yep. It's okay here in the moment. It's okay. It's actually better than okay. This is better than if you hadn't made this mistake. Because now we get to spend time together. And life is about connection. And the SAT is life. We got more, do we? This is all here in the moment stuff? Nice. Cool, we got one more then. Oh, this is set up nicely. Let me just, oh no, we want the answers now. Okay. This is a matrix question. Matrix questions can be difficult, as we see here. Okay. This is about context. Yeah, no problem. So, Valley High School and Mountain High School have decided that selected students will attend a daytime theater, whatever. Yeah, so students cost, $5 for each teacher and $3 for student. So, let me just write that down. So, student tickets equal $3 and teacher, right? Teacher tickets equal $5. Okay, so we have that. 1 teacher and 10 students from Valley High will attend, and 2 teachers and 25 students from Mountain High will attend. Okay, so we have a couple different things. Valley gives us, what is it? 1 teacher and 10 students. So 1 teach, 10 students. And then we also have Mountain. Is that what it is? Yeah. So Mountain has 2 teachers, 25 students. 2 teachers and 25 students. So I'm sure you got there. I mean, I just basically rewrote everything. Now they are saying, which of the following matrix products represents the ticket costs in dollars for each school? Okay, this is a very interesting matrix question. It's not asking you, can you do this multiplication? Although that actually does get rid of E and D. So let's actually start there. Matrix multiplication. How comfortable are you with that here in the moment? My guess is not super comfortable because you picked one that's impossible. What are your thoughts on matrix multiplication? Oh wait, you're doing ACT clearly. Okay, so my SAT comment before not only was stupid but irrelevant to you. I'm just gonna start. I'm not sure if we're lagging or you are. Bird, can you just link to all these anyway on Reddit? It'll be good for us. For you, I mean. What did you say? I disconnected. Oh my gosh. Yeah, so that's how you do this one. And yeah, let's move on. I'm just kidding. I basically asked you, how do you feel about matrix multiplication? Which my guess is not very good because you did it incorrectly. I'm going to get rid of the... where's my mouse here in the moment? Let's drop most of this. We only really need that, I guess, and let's make it a little bit smaller. Okay. So let's do some matrix multiplication. What you did over here, this 5, 3. When I multiply matrices, I move the second one up. Instead of writing the 1, 10, 2, 5 in answer choice E, that's what we're doing right now. Instead of writing that next to it and doing the multiplication, I'm going to move it up. The reason I do that is because it makes the multiplication of matrices more visual, and I think it's incredibly helpful. So we have 1, 10, 2, 25. So we're going to try to multiply these and see what the resulting matrix is. So we start with this first spot here. I'm going to ask you again here in a moment. I'm not sure how much disconnection you're getting. How comfortable are you with matrix multiplication? Because we can talk about that in general, because that's very important for this question. When you multiply matrices and you have them in this setup, you're going to go for this spot here. You're going to go across this row and down this column, because this is first row, first column, so you go first row, first column. You do 5 times 1, and then you have nothing else to do. You want to do 2 times something, but you can't do that, okay? This doesn't work because we can't even get that first spot, because the way we're multiplying them, it doesn't work. This is the general way that I would recommend multiplying matrices. You take the second one, you move it up, and then you start multiplying through. Let me do, let's say A, because it's the right answer, okay? So this is set up correctly, but you're not allowed to multiply these 2 matrices, okay? Can't do that. Let's do 5, 3, and then we have 1, 2, 10, 25. when you multiply these two matrices, your resulting matrix will have a spot right here. Yeah? This spot. How do we get that spot? It's going to be the first row in the first column of the resulting matrix. So it's the row here. You always go across the, oh my gosh. Whatever. You go across the rows, you go down the columns. So what we're going to get is 5 times 1. So we get 5 times 1. This is just how you multiply matrices. Plus 3 times 10. That will equal 5 plus 30, which will equal 35. So this first spot here is 35. Here in the moment, are you just cutting out a lot? If you're cutting out a lot, you can watch this later and hopefully be able to not see it with the cutting out. I don't think it's us. Can you check our stream, Bird, on Twitch?
Yes.
No, you're here. Okay, just, what are you saying? Why he say, oh my gosh, hello? Oh gosh, I don't know how lagging we are, what the latency is. Anyway, does this first spot make sense? Well, you're always going across a row and down a column, and that will create all the columns and rows you need in the result. This is a very small resulting matrix, because we only have one row here, so we can only go across this row. That means our resulting matrix will only have one row. And then this has 2 columns, so our resulting matrix will only have 2 columns. So this is going to be a 1 by 2 matrix. The other spot is going to be right next to it. It'll be the first row again, because we only have one row right here. And then it'll be the second column now. Right? We've done the first column, now we're doing the second column with that first row. So 5 times 2, 5 and 2, plus 3 times 25, which is 10, plus 75, which is 85. So this spot here is 85. How do you feel about that here in the moment? So the result of this matrix multiplication here, the product, is a matrix 3585. That's our answer. So, it's weird. Yes, it is. So, I don't want to talk too much about this question because this is a hard question, even if you know matrix stuff. Hi, Usvo. Do you have questions? Please bring us your questions, but hello. Let's do another matrix multiplication. And we'll use slightly bigger matrices so that we can get a little bit more practice with it. Because you do need to know this stuff. So, I will do it here. Da-da-da-da. Da-da-da-da.
Someone just uploaded more than 70 ACT practice tests from the past years, including like 3 from 2019.
Wow.
Onto Reddit, and it's going to be taken down very soon.
Okay. You know what to do, huh?
I download them. On your computer?
No. It's Chromebook. It won't work. Mine. Why is the matrix grouped that way? Okay. Why did you write the matrix like that from the equation? So this is just a more visual way to do it. You can so basically, let's make up a new matrix thing. I'm going to get rid of this thing. I mean the word problem. Like, why is that the right answer? I'm happy to talk about that later, but I want to make sure you fully understand matrix multiplication. Once we get that underlying concept out of the way, then we can come back to that. Okay? Cool. All right, let me take this down. Okay. Usvo, I am doing this question, but you should definitely ask your own. It doesn't have to be math. It can be English. It can be reading. It can be science. It can be writing. It can be essay. It can be whatever. Whatever you want to do. Okay. So, let's say we have 2, 3, 1, 0 times A, B, C, D. Okay? Those are the two matrices we're multiplying together. The way you do this is Brady has to mime it though like charade. Oh, mime. Usvo wants you to mime the word of the day. Not yet. We can do matrix stuff while you figure out your routine.
I got it.
Yeah, but not right now. I want to finish this.
Take me a second. Fine.
Okay. To do that, this is really hard to do. You're going to have to do, and this is why I do this. So I will explain how to do this, and you will see that it's very confusing. You want to go for the first row, first column piece here. You want to go across the first row and down the first column. So you get 2 times A plus 3 times C. Now, for the next spot, you want to do, it's still the first row, but now it's the second column here. So you do the second column from this one. So you do 2 times B plus 3 times D. 2B plus 3D. This is all one number, one entry here. Just like this was 5 times 1 plus 3 times 10. We were able to combine those. So let's see. Then we have this bottom one here, and it's one. Now it's the second row, and now the first column again. So we have 1 times A plus 0 times C, which just gives us A. And then the last spot is the second row, second column. So we do second row, second column. 1 times B plus 0 times D, so we just get B. Now, that's hard to visualize and hard to remember, I think. So what I recommend doing, it gives you the same answer, but it's just more visually simple, is you have the first one, 2, 3, 1, 0, and then you move the second one up. And then by moving the second one up, you can visually see exactly how big your matrix needs to be. It needs to be the same number of rows here, and it needs to be the same number of columns as this one. And then we will get the same answer, but now we can see what's going on. We can see that we need to do, for this first row, first column, it's going to be here and there. So it'll be 2A. You just go down like that, go across and down. So 2A plus 3C. And then here and there, 2B plus 3D. And then A and B. So they do the same thing. This is a little clearer to visualize the multiplication and addition stuff. You multiply like that and wherever you need to go. It gives you the size of your matrix, and if it doesn't work right away, like now here we have 2 times A plus 3 times C. So that's great. But let's say that we had something like 2, 3, 1, 0 times A or B, whatever, B, C, D, E, F, G. And that's what we're multiplying. Well, looks like we're going to go like that. But then we have an issue, because for this first row, first column, we have 2 times B plus 3 times D, and then we have an F with nothing to do, right? We have 2 terms that went together, 2 sets of terms. But then the F is the third one here. There's no third one here. So we can't do it. As soon as you have a leftover one, it could be left over here, it could be left over here, it doesn't matter. You can't figure out what that is. This becomes undefined. So you just can't do this multiplication. Okay? That's super important. How do you feel about all of this now? This stuff. When you're allowed to do it is when that first try works. If you can do that first row, first column, then you know you'll be able to do everything else. Another way to think about it is, this is a 2 by 2 matrix, right? There are 2 rows here, there are 2 columns here, there are 2 rows here, and there are 2 columns here. These 2 numbers have to match. So when you're multiplying matrices, the number of columns in the first one and the number of rows in the second one has to be the same. So there are 2 columns and 2 rows. They're the same, it'll work. If we have, let's see, A, B, C times W, X, Y, Z, can we multiply these 2? No, we can't. This is 1 by 3, this is 2 by 2. These 2 don't match, right? This is a 1 by 3 matrix, and we're multiplying that by a 2 by 2 matrix. This is row, it's always row, column, row, column. So the columns of the first one have to match the rows of the second one. Columns of first have to match rows of second. If they don't match, which they don't, you can't do this. Sorry, dumb question. Yes, give me your dumb question. Is row horizontal? Yes, the rows are horizontal. So the number of rows you have. It can get confusing, which is why I like setting it up. If you set it up and you try to do it, it won't work if you're not allowed to do it. You will not make a mistake if you just start. So if I just were to start here, I would do W times A, Y times B, but then I have a C left over. So I can't do it, so it's no good.
Tell them.
I like doing it visually, but we can set up the rows and columns like this and do it that way as well.
Tell them the columns are like columns of a building. They're vertical.
Cool. Columns are like columns of a building, right? You can think of it that way. And then rows are the horizontal. Or you can think of it as rows like rowing a boat, and boats are in water, and water is generally horizontal. Think of it that way too. That's probably better. Thank you. Check Reddit. Got it. Do you want me to go back and do this question, or are you fine for now? Because the question number 57, it's a really, really hard matrix question. I would recommend going and practicing a bunch of matrix stuff on Khan Academy and wherever else you want to go first, because this is a very hard conceptual question.
I want the next one.
You want the next one?
Yeah.
Are you sure?
Yeah.
Can you handle it?
Yeah.
That question was doo-doo. Yeah. The ACT hurt itself in its confusion. It looks like we're doing 58, so let's set that up for you, Bird.
Good. I like that.
This looks fun.
I like that.
I'm going to just get rid of the answer choices.
Good. I like that.
Oh, good.
I like this one.
Levi, how was your day?
It was well.
I don't think that's. I don't think you'd say that.
No, my day was well.
No,
Yes,
you can't say that.
I can say that.
No, you can't.
Yeah, I can.
Describing a day, noun. Well is not an adjective.
No, it's well.
No,
Yeah,
no, it's not.
my day is well, fine.
Well, see, that's different. You didn't say that the first time.
I did.
Get out of here.
You
didn't
just
say-
interrupted me.
No,
too
I
early.
did not.
You did too.
No, I did. I did 3.
Oh my gosh, that wasn't very good.
What?
You gave it. Wait, who gave you all the who questions?
Here in the Moment is giving us all the hard questions.
Yeah, we love difficult questions here in the moment. You might not think so, but we do. They have more nutrients.
Yeah. A lot of nutrients.
All right, here, I'll finish it with you.
Thank you. Carrie is inventing a new notation in math. Good for her. She has decided to use n down, is how I'm going to read it, n down, to denote the sum. Wow, Levi, that's terrifying. To denote the sum of the first n positive integers. For example, 5 down means 5 plus 4 plus 3 plus 2 plus 1. Carrie has written 3 statements that she's investigating as possible properties of n down. Which of these statements is, if any, is R true for all positive integers n? Okay. Conceptually, this is going to be quite tricky to figure out. Yes, it's similar. It's like factorial, except instead of multiplication, it's addition. And I would say the right call, yes, exactly, here in the moment. I would say the right call here is to pick a number for n and see if it works for each of these things. So 1 is not really going to help, because 1 all the way down is just going to be 1. It's just like taking 1 to some power. Like, it doesn't really change, so you want to use something bigger. So for fun, let's use 2, and let's see if these work. So for postulate 1, or statement 1, 2 all the way down plus 2 plus 1 would be equal to 2 plus 1 down. Okay. So 2 down is 2 plus 1 plus 2 plus 1 is going to be equal to 2 plus 1, which is 3. So that's 3 down. All right, so we have 3 plus 3. That's 6 is equal to 3 plus 2 plus 1, which in fact gives us 6. Okay, so does this prove that it works? Not in a general sense. In the time it takes you to do this test, you probably want to say, yeah, that seems like it works. You could try with another number, see what happens, but right now it looks like it's going to work. Let's try the next one. So we have 2 down plus 2 down is equal to 2 times 2 down. All right, so we have 2 plus 1 plus 2 plus 1 is equal to 4 down, which is going to be, okay, so that's going to be 6. It's equal to 4 plus 3 does not look good, does not look good at all. 6 does not equal 10. So that is, it's not going to work. Hi, I took the SAT in last Saturday. I heard that part 5 is randomly math or English part. They don't score section 5. They use section 5 for their own future test creating purposes. It doesn't matter. Yeah, it doesn't contribute to your score. It's an extra section that they use for their own. Yeah, it will not matter. Don't worry. Okay, so that means statement 2 does not work. So lastly, let's try statement 3. So let's get a different marker here. We're just kind of going all over the place. So we have 2 squared down will be equal to 2 down squared. Okay, so this is going to be 4 down is equal to 2 plus 1 squared. 4 down I already calculated over here. That's 10. 10 is equal to 3 down. No, sorry. 10 is equal to 3 squared. 10 does not equal 9. Therefore, 2 and 3 are definitely out. 1 looks like it works. Let's take a look at what the options say here. So we have 1 only, 2 only, 3 only, 1, 2, and 3 are none. So it looks like it's going to be F, 1 only. Again, you're not actually creating a proof. For what we did, we just tried it with an example, and it turned out that statement 1 worked, at least with 2. If you try some other numbers, it will continue to work, and you'll be confident that it does, in fact, work. A proof does not involve specific examples of numbers. A proof involves actually using letters to like show that something is true all of the time. But you don't really have a lot of time on this test to create proofs, so don't worry about it. Okay. Excellent. Levi, what do I do next?
Are there any more questions?
On Reddit?
Yeah, or anywhere.
We got Zinli, Sunle, hot and new. I will post more. Give me 1 sec. You are a legend here in the moment. You're doing fantastic work. Fantastic work. Really, really good stuff. Real big fan of your work here. Especially your early work. Usfo! Remember Usfo?
Yeah, who's been commenting?
Usfo, it's been a minute. I don't know when was the last time Usfo was on? Recently? Oh, okay. Well, Usfo, it's still good to see you. I don't care that maybe you were on recently. It's always good to see you, Usfo. Of course, I'm not actually seeing you. I'm making brownies. That sounds exciting. You making brownies with your mom? Or your dad or your grandparents? Or a friend or a sibling? Or alone brownies? Alone brownies are good too. You ever have blondies? Blondies are really good. I thought they were kind of a joke. Like a friend's mom made them. I'm making blondies. It's like, I get it, because they're like the opposite of brownies. But like that's totally you're making them for your girlfriend. Uh-oh. She had a test today. Uh-oh. Girlfriend. Check Reddit. We got another question. I'll check Reddit. Have you given her... Oh, of course. I was going to say, have you given her the brownies yet? But you are currently making them, so that would be impossible. In my SAT room, Invigilator, do the wrong thing. He let us talk in 5-minute break, and I see someone talk about answer and change. In the SAT room, the proctor
Invigilator? He let us talk. So I'm not sure I understand what you're saying. Invigilator? I like that word. I'm not sure what it means though. Sounds like a machine. I am the invigilator. It's something that invigilates.
Invigilator.
Yeah. I enjoy invigilating in my spare time. Here in the moment, you're really all about this language thing, aren't you? A lot of language with here in the
Is
moment.
here in the moment deleting these questions after they post them?
Yeah, here in the moment, are you deleting these questions? Because you shouldn't do that. Because we put a link in the comments. Yeah, and we want, if people see the link, we want them to check it out. It's okay. Just try not to do that again. You didn't know. It's okay. You didn't know. And there's truly no way for you to know. So that's okay. I'm going to do this one, Levi.
Mm-hmm.
Okay. Hey, you know what? You can make up for it. Just don't delete this one. It's one of my favorite ones, too. Which of the following is an equation of a parabola that passes through the 3 points labeled in the standard XY coordinate plane below? So, how are these tutor sessions funded? These ones? They're not. They are totally free. Are we basically giving away our time for free? Yes, we are. How are they funded? Levi, how are these sessions funded?
Oh, okay.
So, this is a direct bartering system where you give us questions and we give you answers. I don't understand your question. But we like it because we appreciate questions. They nourish us, and that's how we fund ourselves.
Yeah, Levi and I have weaned ourselves off of normal food
Mhm.
a couple months ago
Yes.
and completely changed
A
ourselves
year
over.
at this point.
Yeah, although I don't know about you, but I was still having trace amounts of food every now and then. I've only recently, as of a couple months ago, been completely off of food.
Oh, okay, we're gonna have to talk about that after stream.
Sorry to bring
Yeah.
that up here.
Yeah.
But yeah, we've switched over to all of our nutrients are acquired through questions.
Yeah.
And we excrete waste, which are answers.
Yep. Right out the old face butt. SAT math part is not that much time. I finished my multiple choice, but I have no more time to finish blank question.
Ah. So Zill, what you actually want to do is right when you open the math section, go to those free response, those written portions. Wait a sec. Hey, Usfo, 5 bits. I'm hungry for bits.
Yeah, we also eat bits.
Thank you. Invigilator is a teacher who watching you in SAT. I'm still not sure. Invigilator. Talking about like the test proctor? You know, like an invigilator?
Okay, sure. That's
Anyway,
fine.
But okay, yeah, you actually want to do the written math questions first because it's a cinema for proctor. Because you can't guess on those at the end if you run out of time. You can guess on multiple choice and you might get some right, but you can't guess on the written portions. So you should go do those first and do the ones you can. Obviously, if there's ones you can't do, skip them. Do the question?
Well, I don't think you know how. It sounds like you're procrastinating.
No, I can do this
Maybe
question.
I should help you
Oh,
out.
absolutely not. No, I know this question.
Okay.
Okay. This is a parabola. If it's a parabola, that means it's a quadratic. All right? A quadratic. No.
I thought it might help you teach them.
Well, I mean, you're not totally off base in wanting to help me.
Okay.
Here's a quadratic. It is a polynomial that is degree 2, which means the largest exponent we see is 2. Okay? If it's more or less than that, it's not going to create a parabola. So if you take a look at something like C or D, we have 2 factors in all of this. But with D, we have x minus 3 squared. So that's going to give us x squared plus some stuff. And then you're going to multiply by x plus 3, which is going to bring up the total degree to 3, which means you're going to get an x cubed term in that. So D is going to be a cubic polynomial, as will C, as will B. These 3 will all give you cubic polynomials, which are not going to give you parabolas. Only A and E will give you parabolas, because if you multiply everything out, which you don't need to do, but if you multiply everything out, you will only get an x squared term as your largest term. So that's one thing. The next thing, let's talk about factors and x-intercepts. We have two x-intercepts here. We have -3 and we have +3. If you know x-intercepts, so -3 and +3, these are also called the solutions, the roots, the zeros, and they're the x-intercepts. That means you can assemble them back into what their original factors were. X plus 3 and x minus 3. Now all of these answers have those two factors, so that doesn't really help us here. What helps us, though, is eliminating the fact that we don't want cubics. A and E, there's one more thing that we can figure out here. They both have 1/3 in front of them, but A has -1/3. This parabola, just by looking at where the points are, is opening downward. It is a negative facing parabola. So the A value, the leading coefficient, needs to be negative. With A, if you multiply the -1/3 into the mix, you'll get -1/3 x squared as your very first term. I'm not going to multiply the rest of it because it's not necessary to do that. This is going to give you a positive leading coefficient, which means the parabola is going to be opening upward, which is not what this looks like. So, understanding the connection between polynomials, what degree they are, even and odd, what kind of end behavior that's going to give them, whether it's going to be both ends go in the same direction, or if it's an odd degree like 3, you're going to get something that looks like this. And you can turn it into a dance if you want. But if you don't want to, by all means, do not turn it into a dance. My friend always go back to the last section when she doesn't finish. That's cheating. You are not supposed to do that. And if they catch you doing that, then they will throw out your test. You can't go back to a previous section.
Well, you can as long as you let them know you're cheating afterwards.
Oh, okay, so Levi says you can do that as long as you let them know that you're cheating afterwards. Oh, okay, but then your test won't be graded.
Yeah.
Right, but then your test won't be graded. It's really what your goals are. Do you want your test to be scored? Because if you don't, then you should cheat. But if you want your test to be scored, which is necessary if you're applying to college, then you shouldn't cheat. That's kind of I think that kind of sums it up. Excellent. Very good. So, don't delete this question here in the moment. Have you linked it, Levi?
No?
You should do that.
I thought you did it.
Wow, that's helpful. That's also impossible.
You did good?
Ooh. Another one by a different person. This is exciting. That's me. Oh, you're a different person? Don't compare, create. That's you as well here in the moment? Oh.
Yeah.
Okay. All right, all right. All right. Okay. Here we go. There are 66 calories in 15 grams of grated Parmesan cheese, and 59% of these calories are from fat. When measuring Parmesan cheese, 5 grams is equal to 1 tablespoon. Which of the following is closest to the number of calories from fat per tablespoon of grated Parmesan cheese? Okay. Okay. This is almost like a chemistry question. This is almost like stoichiometry a little bit. Some unit conversion, dimensional analysis type situation. So let's analyze. First thing they tell us. 66 calories in 15 grams. So one thing that we can figure out from that is how many calories per gram are there. That might be helpful to find. Let me erase this, and then we'll do it. Okay. So we have 66 cals per 15 grams of Parmesan cheese. All this is Parmesan cheese. All right, if we divide this, we will get calories per gram, and that might be a little easier. Everything is divisible by 3. I'm going to divide by 3. I get 22 over 5, which would mean we have 4.4. Multiply by 10, by 2, 4. Yeah, exactly, 4.4. And this is calories per gram. Okay. And 59% of those calories are from fat. So 59% of calories are fat. Okay, fantastic. So if we find the number of total calories in the tablespoon, then we can just go straight from that to the amount of fat that must be. So, tablespoon of cheese. So 1 tablespoon. Now I'm going to get into doing dimensional analysis here. 1 tablespoon. Every tablespoon has 5 grams. So I'm going to put 1 tablespoon times 5 grams. So now we're at 5 grams here. And we know that every gram, so 1 gram, has 4.4 calories. 4.4 calories. And then this will give us the total number of calories there are. I could actually go one more step and say, what's 59%? But we're just going to calculate this for a sec. So 5 grams times 4.4, it's going to be 22.
Why not 3, my lord?
Maybe. 22 calories. So that's 20 plus 2. Yeah, 22 calories. So there's a total of 22 calories in 5 grams. And then 59% of that is from fat. So we just have to figure out what 59% of 22 is. So we do 22 times 0.59. Notice that that is more than half. So this is going to be more than 11, which means it's going to be 13 or 22. But it's not times 1. That'd be way too big. 22 times 1 would give us 22. So k is too much, which means it's got to be j. If I multiply this out, it'll probably get us around 13. They say which one is the closest. But it's going to be around, around 13. All right, here in the moment. Was that here enough for you? Was that in the moment enough for you? Don't compare, create. I like the sentiment behind that. I'm not sure what it means, but it sounds artistic and vaguely artisanal. It's good for you.
That is very dumb, Freddy.
Yeah, if you're into that sort of thing.
Quite dumb.
You gonna link that, Levi?
Are you? Yes.
You gonna do the next one?
Yes.
I think you'd like it. I think you'd like the next one, Levi.
Do you now?
But first, I have a gift.
I cannot yet link it, unfortunately.
Pretty wild, huh? Yeah, that's right. Brady's picking up a new instrument. Woo! And I'm having a good time. Yeah, that's right. I'm wild. I once have been described as the personification of this instrument. Here in the Moment's got a new one. Levi, would you like to do it?
Yes, my lord.
Very good.
Would you like to see me do it?
Yes, my lord.
Yes, lord mine. Yes, lordy mine.
Good.
Brother mine.
Hey, why don't you get on it, huh?
So what is this Invigilator situation? Invigilator is like a proctor as in a human being, or I'm confused.
Yes, the proctor is a human being.
Take me back, Josephine,
Do you know the formula for this one?
to that cold and dark December. Something like that. Oh, no, but I can figure it out.
Good luck figuring this out.
Yeah, it's pretty straightforward. Okay. There are a couple ways to do this problem, namely 2. We don't know that this is a 30, 60, 90, so that is an easy trap to fall into. We have a 30-degree angle, we have a 12, and we have a 13. Do not get your wires crossed here and say this is a 5, 12, 13 right a 5, 12, 13, 30, 60, 90 triangle. That is not true. That triangle does not exist. So we have to find the area of this triangle in square inches of, whatever. Okay, so I'm going to do law of cosines.
You're going to have to do Huron's formula.
Yes, you could do law of cosines, but then you still have the same issue. To find the area of a triangle, you have to do base times height. I will do the faster way, which is Huron or Huron?
No, you're not doing Hurons.
No. Are you, though?
No, no one's doing Hurons.
Okay. You're doing here in the moment formula?
Doing that?
Yeah, no, I got you. So, the area of any given triangle is going to be 1/2 AB times sine of theta, where A and B are getting the, the angle theta is created by sides A and B. Okay? So in a triangle like this, if this is A and this is B, this must be theta. Okay? So for this triangle over here, if we do 1/2 AB sine theta, we're going to get 1/2 times, A and B are 12 and 13 respectively, times sine of 30 degrees. That will just give us the area. Hi, Jerklump, by the way. The king is here. Jerklump is no true king. He's just pursuing power. But you here in the moment, you didn't ask for this. It was thrust upon you. You must take up the mantle of your uncle, the former king. Uncle. Great. So, this is just one way to do it. If you remember this formula for any given triangle, you have to know that the A and the B, those side lengths have to create that angle theta. You can just use this formula. It's super fast. I will tell you why it's sine. We can derive this pretty easily. So I'm going to redraw this triangle over here. We have something looking like that, right? And we have A, C, B, 30 degrees, 12, 13. Okay, so the area of a triangle is base times height divided by 2, right? 1/2 base times height. Let's see if we can create this from that idea. We need to find the height, though. That's the only thing. If we say the base is 13, we can find this height here. Yeah? So what is that length? Using trig, we can find it. If this is 30 degrees and that's 12, we know that sine of 30 degrees equals opposite over hypotenuse, which would be h over 12, which means that h equals 12 times sine 30. Now we have the height and we have the base. So we put them together and we get, and now we have 1/2 base times height. This is our height, this is our base. So the area will be 1/2 times that base times that height. And we get 1/2 times 13, which is that 13, times 12 sine theta, sine 30 in this case. So it's derived from this situation, okay? If we make everything, if we turn these into A and B, we would have, doesn't really matter which is which, but let's change it. Let me just erase all of this. How do you feel about this stuff? Now, do you feel okay with this being sine? You don't have to necessarily know exactly how this is derived. You can remember it, but honestly, the better skill is to know how to do this. You know how to find the area of a triangle. It's 1/2 base times height. This is slower than this, if you remember this, but this idea of using trig to be able to find a side length that's not even written in the first place is a more generalizable skill. So let me just do this real quick. If this is, let's say this is B. Well, no, it's not B. Let's just change this up entirely. Let's say that's C, so that I can keep things the way I want them. I have no follow-up, yes, it's okay, here in the moment. How do you feel about this being sine? Did you like that stuff or not so much? If this is B and this is C, easy. Yeah, it is. Okay, then maybe. I'll do it anyway. This is theta. This is side A because that's angle A. This is side B because that's angle B. And now we know that this height right here is going to be equal, because we say that sine of theta equals the height over a, right? The opposite of this angle over the hypotenuse, which is a. Now we multiply by a on both sides. We just get that the height is a sine theta, a times sine theta. Now we have the base, we have the height, so the area is 1/2. We have b, we have a, so it's a b sine theta. That's how it is derived. It's very fun. Everybody is having a good time. That's what everybody says. That's what you say.
I never put that together before.
Yeah, that's where it's from.
Makes sense.
Pretty hip hop. Okay, let's do more stuff. Do we have more stuff? Yeah, we do. Do. Don't compare, create. That's right. Oh, we got 2. It looks more like we're only doing this one. Okay. Oh, this is fun. This is a fun one, Bird. What can help on this one here in the moment is that the right answer, it seems like, on all your tests is circled in red pen. So if you look for the red pen, you probably have a better shot at getting the right answer. Just one of those guessing tricks that I like to say, you know? What's the bruh for? Don't bruh me. Jerk lump. Hello. Bird, you're gonna like this one.
You think so?
You're gonna like the way you look. I guarantee it.
Really?
Oh yeah.
You're right. I like the way I look.
Go.
Oh, I do like this one.
Hey. Sorry, I actually didn't realize that.
Yeah, you did.
I did not.
Sure.
Do you have a child right after this, by the way?
Yes, I do.
Nice. Oh, do you have a calc child, or can I have that packet?
You may have that packet.
Where is
Yes.
it? In the room, and then where? In the room.
Oh gosh, I think if you go up to my desk, the left desk, that top shelf you pull out, I have a packet of a bunch of different papers, and it's somewhere in there.
Jerk lump, how old you?
All right, I'll get it for you. So after this question, you don't have to go get it. That's fine. Which of the following quadratic equations has the complex number 1 plus the square root of -1 as a solution? Well, one thing to keep in mind is that complex number is 1 plus I. That's what the square root of -1 is. It's I. All right, so that's something. The next thing, which may help us, may not, in fact it won't, is whenever you have a complex solution like this, they always come in pairs. So 1 minus I will also be a solution. That's something to think about. Kind of fun. Okay. The next thing is these are complex solutions, which means they're not real. These quadratics. There's a fast way to do this, and there's kind of a slower way to do this. If you have quadratic formula on your calculator, and we have calculator programs on our Discord, that it gives you the instructions for how to put them on your calculator. You need a cable. You also need a TI-83 or 84 or something like that. You can download the quadratic formula on your calculator, and you can plug in, A, B, and C, and it will tell you what the roots are. And if the roots are 1 plus I and 1 minus I, you've got your solution. So that's one thing you can do if you have quadratic on your calculator. If you don't, I suppose you could do the quadratic formula on paper, but I don't know right now. I can't graph functions. Okay. Here in the moment, what you need to, no, it didn't break your calculator. What you need to do is open up ACT again and go down to quit. You need to officially quit it. It's hard to quit. If second quit doesn't work if you're on the ACT program, you need to literally go down to 7 quit on the main menu, and then your graph will be free again. And if it turned off your axes and things like that, let me know, because I can tell you how to fix that. Yeah, it's one of the things is that the program hijacks your grapher, and if you don't officially quit it, it will turn off my access. Yeah, so you go to second zoom, which is format. And on format, you go down to axes, and you turn them to black. Right now they're off or something like that. Do you have your calculator with you? Yeah, if you do, follow my, yes, you do. Okay, yeah, so go to format, which is, I believe, above either window or zoom, one of those. You do second and then that. And then go down to axes and turn your axes back on again by choosing a color. And then you should be good again. So, use quadratic formula, find the zeros. Okay, that's something. The next thing you could do, if you don't have quadratic formula on your calculator, if it's a graphing calculator, you're welcome, has I on it. Okay, so if you say 1 plus I, and then you store it, so there's that button that says store, and then you press the X button and then enter, your calculator will save 1 plus I as X. And then all you have to do is take X and write out all these different equations. X squared plus 1. It'll give you what X squared plus 1 would be. If it's 0, then it's right. If it's not 0, then it's not right. So that way you could just type all these in, and one of them will give you 0, in which case you're done. So that is another way to do this. Those would be the faster ways to do it. And then, you know, if you don't have that kind of functionality in your calculator, then we could talk about doing this and solving these very quickly. F is the easiest because there's no middle term, so you really don't have to do the quadratic formula. You would just need to subtract 1 on both sides, so you get x squared is equal to -1. Take the square root of -1, and you get x is equal to plus or minus I, which is not what these are. So that's not going to be the answer. Another thing you could do, okay, I mean, we can do all this stuff. It's just, I don't want to have to do the quadratic formula for all these. Let me think if the discriminant can help us here. So are these all going to give us complex solutions? So we have 1 minus 4, 1, 1, which is going to be negative. 1 minus 4, so wait, yeah, b squared, which is 1 minus 4, 1, 1, also negative. Minus 4. Oh, you know what? J is going to be 4 minus 4, 1, -2, which is going to be nice and positive. And then K is going to be 4 minus 4. Yeah. So J is the only one that actually has real solutions. Its discriminant is positive. And if you graph it out, you'll see that it actually crosses the x-axis twice, so the solutions are real. So J is not going to be right because we know our roots are complex. So F and J are out. You know, like at this point, what I would have to do for you is do the quadratic formula for all of these. I'm not going to do that. I'll show you why K is right. With K, we have A is equal to 1, B is equal to -2, and C is equal to 2. 1, -2, 2. So quadratic formula would be minus B plus or minus the square root of B squared minus 4AC all over 2A. And then we just start sort of simplifying it a little bit. We have 2 plus or minus the square root 4 minus 8. Negatron 4 all over 2. Square root of -4 is going to be 2i. So 2 plus or minus 2i over 2. All the 2's cancel. You get 1 plus or minus I. And that creates our two roots, 1 plus I and 1 minus I. No, here in the moment we don't. Here in the moment, you have the program. Go to Quad. Quad will do this for you. That's what I was saying in the beginning. You don't have to do this by hand. If you know your way around a calculator, then you can let it do the work for you. So go to the ACT program and go to Quad, which is number 2 or number 3, and put in A, B, and C. And it'll solve it for you. And you'll see that this last one, the roots are 1 plus I and 1 minus I. Because no, we do not have to do this all by hand. You could, but it's going to take a while. It worked, thank you. Of course it worked. We're nerdish. What do you expect it to do? Not work? Boing. Okay. Very good. Very good. Master Levi.
Did you link this?
No, because Twitch had not yet created that part of the video yet.
Oh, very good.
But it has now.
Heyo. That's what I'm talking
You
about.
probably didn't know that.
Well, you know, I know some things. Okay, I'm gonna turn that off for now.
For now.
Here in the moment, don't refresh the page. I am ranting. The science section. Levi, do you like this?
No,
Do you feel like it's made me a better or worse person?
I think it's made me angrier.
Yeah, what about me?
I don't know.
You're out of questions. Well, we're fresh out of answers. Oh, Jerklump!
Hey, Jerklump.
We'll take practice test and postmortem tomorrow. Excellent!
Yes.
As you should. You got this one, Levi?
I don't know. Wait, which one?
Jerklump.
Oh, we got a reading question. Very exciting. What is this from a test we recognize?
Oh, Stevenson.
What test is this?
I don't know, but I've done this before.
Okay.
Do you remember the one about Robert Louis Stevenson?
No.
All right, I'll do it then.
Can I do it with you?
If you want.
Yeah.
Okay. All right. Is there a
All right,
trick?
Is there a trick?
There's not a trick.
There's not a trick.
Levi, what are you
Levi,
doing?
You are what?
I mean, there's certain tricks
there's
for math
certain
questions.
tricks for math questions.
But this is a reading comprehension question. So let's go to the question and read it right now.
As it is used in line 3, the phrase, I don't know what that
The
says.
rougher fringes
Yes.
most nearly means the same thing as which of the following phrases. So, of course, we want to go to line 3 to start. Okay.
I will do it, my lord.
Will you now?
Line 3 is not even on here. Oh my gosh, there it is. That's
Okay.
exciting.
Go ahead, Levi, and just, we're going to make this, here we go. Make it huge. Just read the beginning till 3.
Oh yeah?
Yep.
Okay. Robert Louis Stevenson,
1850 to 1894.
preferred to circumnavigate civilization with its increasing reliance on contraptions and steer toward the rougher fringes.
Okay. Circumnavigate is a word that means to travel around. So the first person to circumnavigate the globe, which means to sail around the entire planet, I believe was Vasco da Gama.
I think it was Amerigo Vespucci.
Was it Vespucci? No, he was. No, that's why we call the country America. He was the navigator for Columbus.
Was it Pocahontas?
It was Pocahontas. She was the
Yeah.
first one to circumnavigate
Yeah.
the entire globe.
Yeah.
Sit down. Stay up here. But don't say that again. Okay. I'm literally drinking air freshener.
That's literally
That's
impossible.
very good. Okay. So to circumnavigate civilization means to go around civilization. So, yes. What do you want?
Pocahontas?
Sit down. Okay. He did not like all of the progress that civilization was making. It says he self-consciously turned his back on the Victorian idol progress. So, steering toward the rougher fringes, if you go around civilization and not straight through, you're going around to where progress isn't really happening, which is kind of the underbelly, the backside of civilization, where things are rough, not, comfortable and smooth and things like that. So, that's kind of where this is going to go. Rougher fringes. Things are not as nice. Probably we're talking about roughing it outside, maybe some poverty, things like that. So which would be the same as that? Number 9, The Fire of Adventure. Let's see what that says. The Master of Ballantrae are set in all these books. His most popular novels are set in a semi-mythical realm where the fire of adventure catches on every page. So the Fire of Adventure is referring to his novels. That's good. Referring to his novels, not really his own life, because this is not taking place
in his own actual life. Him steering towards the rougher fringes is real life. B, an epic ocean voyage, 32 to 33. Let's see. And the vagabond was precisely what he set out to be. Long-haired, careless about food, walking through France, or planning an epic ocean voyage. Okay, interesting. That's like outdoors, and it's roughing it, basically. I mean, you can be comfortable on a boat if you're wealthy and live in the wealthy part of the boat. I mean, this is old, so we're talking about wooden ships here. But anyway, we're going to keep looking. That might be it, that might not be. C, a glittering hieroglyph, line 64. Let's see what we have here. That didn't work. Okay. Here we go. Okay. It was while standing on Hampstead that this is hard to read because it is kind of, okay. The design of the something city flashed in the vision, a glittering hieroglyph. He was talking about the lighting, the new electric lighting of the city is what he was referring to. So there's that, which is not really the rougher fringes, that's progress. So that's not what he's into. And then the last one is D, Skirts of Civilization, 69 to 70. Not for him improvements in something. Give him the flickering gas lamp and the Skirts of Civilization any day. The skirts, think about like what a skirt of a Christmas tree is. I mean, that might, it's you know what, forget that, jeez. If you're, skirting around something, it means you're on the outside of something. The skirt is kind of the thing that goes around something. Levi, what other things have skirts besides like the clothing option? A skirt goes around you. That's one thing. It doesn't go through the center of you because that would be cutting through your body.
Yeah.
The
like
outskirts.
a lot of animals have skirts.
That's
Yeah,
not true. That's not true.
That's true. It is true. It is true.
An animal has a skirt?
Yeah, no, not the clothing skirt, but like there's a skirt of like tentacles or little fronds or whatever.
Okay, I don't think they're referred to as skirts.
They can be.
Think about the outskirts of a city. That's the outside range of it. Okay, so he's steering toward the rougher fringes. That's like the outskirts of civilization.
Skirt steak.
Rip. Skirt steak. Yeah, that's helpful, definitely. Yeah, exactly. It's the outer part of something.
Oh, you know what I was thinking of? I was thinking about animals that are killed, like leopards, to be leopard print skirts.
That's what you're thinking of?
Maybe.
So it's what I said to not think about, which is the clothing option.
It's really hard when you tell me not to think about something, because then I think about it.
That makes sense. Oh, good luck to him. Trying to apply to MIT. Well, if he's trying to apply to MIT, as long as he applies to it, then he succeeded in applying to it. So that, he just needs to submit all the things.
That's a ridiculous thing to say, Brady.
Well, he said he's trying to apply to MIT.
Maybe.
Yeah, hopefully, getting in MIT is a totally different thing, but as long as some of us are miserable. Why are you miserable? Because of my comments that are dumb and misinformed? How can I make you happier here in the moment? Is it because you're in high school and there's a lot of pressure and college is coming up and, what's going to happen to you and, boing? Why are you miserable here in the moment? Misery happens. I'm good with going to state school with zero debt. Yeah, as you should be. Debt's ridiculous. If you can avoid it, avoid it. There are some very good in-state schools in most states, I would say. And you can save a good deal of money with that. Here in the moment, why are you upset? Why are you miserable? Levy,
Yes, Bird.
what time is it?
Oh, yes, Bird. Always, Bird.
Very good, great.
It's 8:49 p.m., Bird.
Because you're a failure, Bird. You're not I don't know you very well, but you're not a failure. No, you're not. Okay, so let's imagine that you were a failure. What would that mean that you should do? Like, you can't just stay a failure. You've got to pick yourself back up again. It's not a end all be all that you're a failure. And you're also a child. I'm assuming you're a high school student. So you got a lot of time.
Though their type of high school student, this is the type that doesn't like being called a child.
Sorry. Well, in recommendation, sorry, not recommendation. I just read that word. In reference to us, relative to us, you're a child. Now, of course, you're not a small child. You're a big child. You are a teenager who's not really a child anymore. You're not an adult yet, I guess is really what I'm trying to say. So you've got a lot of time here to. You're not a failure. I assume you're not. You definitely think you are. Sounds like it, but it's. You don't worry. You're gonna be fine. You don't think of yourself as a failure. Don't call yourself a failure. Everyone has to make mistakes. Repress and dissociate. And if you really don't like the way you feel, you can always repress and dissociate.
Or you can, to counteract that, you can compress and elevate. But that's for broken bones.
Isn't repress?
generally.
Wouldn't it be express?
Yeah.
Yeah.
But I said compress and elevate because that's what you do with like a twisted ankle or something, you know?
Oh, that makes sense. And then ice it.
Yeah.
Yes. What am I gonna do with this guy, huh?
You're gonna start a business with me.
I already did.
Let's start another business.
Another business?
Yeah, one that makes more money.
Oh yeah, that sounds awesome.
Yeah. We're gonna go do that. Actually, we're not. We have a little bit of time.
Business
Partners.
Business part.
What major are you planning on going into pre-med? Is pre-med a major?
At some schools.
Hmm.
Preemed. Remember when you thought that preemie was preemie? So if you're born premature, they casually refer to you as a preemie because you're premature. But Levi thought they were saying preemie, and you just had you didn't know why they said preemie.
No, I did. I thought it was prenatal.
Prenatal, before birth,
Yeah.
which makes sense.
It does make sense.
Because if you were born early, that means you're still before birth.
Yes.
No,
Yes.
you're before the due date that you were supposed to be born. Still, prenatal is before birth. Prenatal vitamins, things like that.
No.
How
No,
would you
because the
think
woman
that?
who's taking prenatal vitamins, she's been born already.
Oh, that's what it is. Okay.
It's referring to
I
the
didn't
mother.
realize how much I hated you until right now. That's what it is.
Dude, you always move. I always let you do things and I don't move, and then you always move.
Oh, sorry. There you go.
I hate that noise.
Thank you for streaming. Thank you for absorbing our stream.
Yeah.
You're very good at absorbing this. I don't apply until next year, so I still got time. Still got time.
You should practice by applying this year.
Yeah. Hey, I'm Jerk Lump, and I still got time.
Hey, I'm
Lump.
Jerk Lump and I'm a junior in high school. I haven't graduated nor will by matriculation 2020. I apologize.
Hey,
Start
you're
with
gonna say, yo, Jerk Lump, you're 45. You should get married. Nah, I still got time. Stuff like that. Jerk Lump, you're 127. You should be dead by now. Nah, I still got time. Add one to the mix.
Hey, Jerk Lump. What's up?
I still got time.
I always ruin those.
I'll live forever. Yes, you will, Jerk
Yeah,
Lump.
Jerk Lump.
You know the first baby to reach 200 has already been born?
Really?
Yeah, he was born.
Is it a preemie baby?
No, he was born in Missouri last year.
Yeah?
Yeah.
Did he already reach 200?
No,
Oh.
but his parents are really proud.
Yeah. What extracurriculars did you guys have in high school?
Like, was that we could do, or
I
the things that we
still
actually
have a
did?
couple of them in my room where I live. But Brady, you lost most of yours.
Yeah, most of my extracurrics kind of rusted, and so
Yeah?
eventually I had to just put them in the landfill.
Yeah, I was able to combine them into like a couple easier ones.
They probably cured cancer.
Yeah, we did, and then we uncured it because people were mean to us.
Yeah. Apparently, there's a lot of money involved in radiation and chemo and
Yeah.
the lobbyists.
They're always lobbyists.
Dude, there's so many lobbies just to
Yeah.
stand around in,
Yeah.
have hors d'oeuvres in. Do you mean like what did we do, or like just what did our high schools have to offer? I assume it's the first one that you want to know. Oh man, what did I do? I did a lot of theater. I did like a math and science engineering thing. I was in National Honor Society. I was in like a mentoring program. I did this fundraiser thing called Project Dance. I made announcements, like morning announcements, for a school spirit group. What about you?
I ran track. I was a peer counselor. And I personally think I wrote a pretty bang up essay. Mine was about an old man that I met, whom I met, and I thought he was very boring. But then I got to know him. That was my essay.
Here in the moment, you don't have to do all the stuff that I did in high school.
Unless you want to get into any college.
Here in
You
the
do
moment.
everything.
Okay, you have to take. So you have to take care of your siblings. Talk to Levi about writing an essay because, like, if colleges see that, then they have some context for like why you might not have been as involved as you could have been. But also, you probably learned a lot and have a lot of valuable life experience from taking care of your siblings. So that could be a nice hook.
Yeah, just keep them alive until you get into college, and you can.
Cease taking care of them.
Yeah. Or
Wow. Really?
siblicide. You have to go. My child's canceled, so I have 10 to 11.
Okay.
Yeah.
In which case, let me just.
Oh, right.
I gotta boing my way out of here.
Okay. Have a good night, everybody. I'm gonna stop this.